All right, good evening, good morning, good afternoon, good night, depending on when you're watching this video. In this video, we're going to look at some exercises of finding probabilities using the student t-table. So probabilities from the student t-table most often turn out to be ranges for the possible value that we are interested in. And this is just because of the setup of the table. The student t-table only provides you with 5 areas to the right of the value of interest. So usually we're going to be in between two values and therefore have to find a range, right? So for example, in step 1, it says, what is the probability t is greater than 2.502 when n is equal to 46? Okay, so first off, in order to work with the student t-table, we have to find the degree of freedom. So this means that our degree of freedom is equal to 45. Now, just like with a normal table, it's always helpful to sketch out what you're looking for. Right, so in this case, here's my student t curve. This is going to be t equals 2.502. And what I want is this red shaded part here, right? So this is the probability that t is greater than 2.502. So I go to my t-table and I'm looking for the 45 degree of freedom line. So that's right here. This line down here. Now what I'm going to do is take my value, which is 2.502, and I'm going to check to see where it falls. Okay, so I start with the first number, 1.301. 2.502 is bigger than 1.301. So I move to the next value. Okay, 1.679. 2.502 is bigger than 1.679. So I move to the next value. 2.502 is bigger than 2.014. I move to the next value. 2.502 is bigger than 2.41, right? But it's less than the next number, which is 2.69. Okay, so that means that our t value, 2.502, is in between 2.412 and 2.690. Okay, so we're in between these two numbers. So we go up to the top of the table and we take the two areas that correspond to those values. So 0.01 and 0.05. So the t-table is telling us that the probability t is bigger than 2.412 is equal to 0.01. The probability that t is greater than 2.412 is equal to 0.01. And the probability that t is greater than 2.690 is equal to 0.005. Okay, so that means that the probability t is bigger than 2.502 is in between these two numbers. Okay, so therefore, the probability, or 0.005 is less than the probability of interest, which is less than 0.01. Okay. And that would be an answer, or that is how we write a probability from the student t-table. And this is the same thing as saying that the size of this area here, so 0.005, is less than this size, which is less than 0.01. All right. So with the student t-table, we don't round to the closest number. We use the number as it's written. And if it's in between two values on the table, then we build a range for the probability. And notice that the direction of the signs here, you always eat the bigger number. So 0.01 is bigger than 0.005, which is why I'm eating to the right. All right. In number 2, it asks, what is the probability t is less than negative 2.056? Okay, so again, first off, n is 20. So our degree of freedom here is 19. And then what I'll do is I'll sketch out a curve. Okay. So this is my student T curve. All right, now I have negative 2.056. So what I want is this portion here. Okay, so how do I figure this out? Right, so this here is the probability T is less than negative 2.056. So this is the probability T is less than. Okay, so to figure this out, I use the exact same technique that I used in problem 1. So because the curve is symmetric at 0, okay, so I can say, since student T curve is symmetric, the probability T is less than negative 2.056 is equal to the probability that T is greater than 2.056. Right? So this is the same size. So the negative tail, or the area to the left of the negative value, is the same as the area to the right of the positive value. So what I can do is figure out, using the same technique from the first problem, what is the probability that T is bigger than 2.056? And that will be the same thing as the probability that T is less than negative 2.056. So in this case, I have 19 degrees of freedom. Okay. So I scroll up to 19. My test statistic is 2.056. So I'm just using the positive. 2.056 is in between 1.729 and 2.093. Okay, so that means that the area that I'm interested in is between 0.05 and 0.025. Okay, so here I can say, since 0.025 is less than the probability T is greater than 2.056 is less than 0.05, then 0.025 is less than the probability that T is less than negative 2.056 is less than 0.05. All right. Now the last one says, what is the probability T is greater than 3.365 or T is less than negative 3.365 when N is equal to 34? All right, so I have DF is N minus 1, which is 33. I sketch out my student T curve here. Which is 0. Okay, and it's centered at 0, sorry. So now I'm going to mark down both values. So in the lower tail, I have negative 3.365, and in the upper tail, I have positive 3.365. Okay, and what I want are those two areas there. I want both of those combined. Now, the trick to this problem is to, again, use the symmetry of the curve. So because the curve is symmetric, we can write that the area to the right of positive 3.365 is equal to the area to the left of negative 3.365. So their total is just 2 times the area to the right of 3.365. Okay. Just need to make a little bit of space. All right. So I can say, same idea. So since curve is symmetric, the probability that t is less than negative 3.365 or t is greater than 3.365 is 2 times the probability t is greater than 3.365. Okay, so now all I have to do is use the same technique that I used in the first two parts. So I go back to my student t table, right? I look up 33 degrees of freedom, which is right here. And now I'm going to scroll across the line and look for where 3.365 fits in. Now, in this case, 3.365 is bigger than the biggest value. So the largest value listed on the table is 2.733. Our value is 3.365. So what that means is that the area to the right of 3.365 is going to be less than 0.005. So we would write here, probability t greater than 3.365 is less than 0.005. Okay, so therefore, since the probability that t is less than negative 3.365 or that t is bigger than 3.365 is 2 times that previous probability, we would have that this thing is less than 2 times 0.005. So this is less than 2 times, or this is less than 0.01. So we simply multiply the bound that we have by 2. And this is my solution. Here. Okay, so question 1 is actually an example of how we would find a p-value for upper tail tests. Question 2 is an example of how we would find a p-value for lower tail tests. And number 3 is an example of how we would find a p-value for two-tailed tests. All of these we will need at some point at some points in our hypothesis testing studies. Okay, as always, if you have any other questions, please let me know.